So let's look at third law of motion now. So from the last law and one of the last theoretical video, we saw that force is local. There was a statement that force is local. That is, everything happens at the same time and so on and so forth. As a continuation, we have the third law. So let's recall the laws. First law is to do with, let me take the screen. First law is to do with when an object experiences no force. It is aram say sleeping and dreaming. Or if it's moving, it'll just cruise. So it's cruising at a constant speed. Either of these two are happening. The wheel can be better. Yeah, I think that's better. So either of this or this is happening. That is, there is no force, or the better way of putting it across is net force is zero. Now that's to do with your first law. Second law is to do with when you apply the force, right? When you do disturb it, then what happens? Okay, supposed to be he was, sleeping and we woke him up. Does it look like that? Yeah, I think so. So here the net force is non-zero basically. It can be either positive or negative. It can be that the object starts moving, or it comes to a stop, or it changes direction, so on and so forth. Right? Then the third law is to do with what happens to the source that applies the force. So that's that. Okay, again, I'm still in the kit mode, as in 6th grade, 7th grade content writing. So I'm drawing and all of that. But yeah, I hope you guys enjoyed a small set of pictures from my end. Third law of motion. So the person or the thing which applies a force also experiences a force of the same magnitude but opposite direction. Okay, I apparently have a video. I don't remember it. So let me also have a look. So we are looking at the first and the second one. Okay, this video. So this is for 9th graders. So we have 50 centimeter chalk marked, and this is the middle. So because the force is equal and opposite, okay, on releasing, can you see that? Exactly at the center. And one more. Now I'm pulling it to, if I remember right, 60. Okay. This is 30 centimeter in the middle, if I'm right, or no. Somewhere over here. Okay. I don't remember the setup, but point is, this is happening. Because the force always comes in pair, equal and opposite. So for every action, there is an equal and opposite reaction. This means that when one object exerts a force on another object, the second object exerts a force of equal magnitude in the opposite direction on the first object. Things to keep in mind. Force, that is action and reaction, always comes in pair. They're equal, they're opposite, they act on the different object. So there are a few questions based on this, so you need to know that they act on different object. Newton's third law is applicable irrespective of the nature of force. It is applicable for mechanical, gravitational, electrical, or any other nature of force. Now, the force, that is the action and reaction, can mutually cancel each other out. So is it true or false? So let me explain the question. So that is one question you guys can get. So if you have an object, and if you are applying a force of 10 Newton, and one more person on the other end also applies a force of 10 Newton. Now what is the net force? It's zero, right? If it's along the same line and all of that, all of this is in the same line, then the net force is 0. You guys agree? Now, is that happening over here is the question. Is the action and the reaction cancelling each other out? The answer is no. But why no? So you have an object. You are pushing it. Okay. So I can draw a better hand, I guess. Yeah. You are pushing it. And the object pushes back. And both are, say, 10 Newton. And this is also 10 Newton. So is it not similar to this? Answer is no. Why? Because when you look at it separately, the hand is experiencing a force 10 Newton to the left, while the object is experiencing a force 10 Newton to the right. So the action and the reaction, this is the action actually, and that's the reaction. They are on opposite objects, and so they don't cancel each other out. So that's the answer for this. Right, one last thing, we need to learn to represent action and reaction. So if you have an object, say because of gravity, it's getting pulled, and because of gravity, this is also getting pulled. Okay, so actually both are equal in magnitude. So the length will be same. So I guess this. So if I call this as object 2 and say this is object 1, this force is F. Again, it depends on which book you guys are using. F21, that is force exerted on 2 by 1. This is force exerted by on 1 by 2. Okay, so this is how you represent, and F12 in terms of magnitude will be equal to F21, but when it comes to direction, they will be opposite. The forces are equal in magnitude but opposite in direction. So this is the funda. Okay, so what do we have? Yeah. And representation, I have done that over here.